In this lecture, we're going to cover some interesting edge cases from our implementation so far with our workers gathering some supplies. Let's go. If we take some worker, tell them to gather, let's say this mineral right here, and before they can complete the gather, we issue another command, which is totally a feasible thing that a player could do. We'll see that the gatherable supply is still busy. So if we tell that worker to come back and gather that same mineral, we'll see that they give up on that one and move on to the next one. So with a series of bad decisions, we can actually freeze out our workers where they don't have anything to do because all of our minerals are labeled as is busy and there are no nearby minerals for this worker to gather. That's a more complex problem than the second problem we're going to solve in this lecture. Let's re-enter play mode to reset the state and select a worker. For me, worker 6 is good. And if we right-click on some minerals, we'd probably expect them to move to that mineral and gather it. But we see that they're just moving to that location. If we want them to gather, we have to click gather, click on the thing, and that's just not very convenient. Do you know how we could solve that without any code changes at all? Here on the worker, we have a list of available commands, and we iterate over each of these one at a time and identify which one can execute. And the first one that can execute is the one that we take. If we simply reorder that, where move is not the first option, but instead other higher priority actions such as gather or in the future attack are earlier in this array, then that action will take precedence over any further ones down. So with this very small change, just reordering that array, let's apply that prefab to worker. Go ahead and click play again. Now all of these workers, when we tell them to gather, should actually gather, and we can see that they're doing that because they're picking different minerals to move to, all with a single right click. That feels a lot better already. One problem down, let's come over into our VS Code. On our gatherable supply, our iGatherable says we can begin and end gather, but it seems like we need some ability to abort gathering where we don't give them the amount and we don't subtract our amount. So on our iGatherable interface, let's add a public void abort gather. On the gatherable supply, let's go ahead and implement that with a public void abort gather. And the challenge for this lecture is to implement the abort gather function on that gatherable supply. So think about it, what needs to happen in there, implement that, and I'll see you back here in just a minute. All right, welcome back. With how some of the previous challenges were, this one maybe was deceptively easy. The only thing we have to do in abort gather is set is busy to false. We don't need to do any of this subtracting the amount. We don't need to do any object destruction. Much like begin gather, it's very straightforward. We're just toggling something about our is busy. Now let's come over into our gather supplies action, because this is really our problem. We begin gathering, and on update, we potentially will end gather, but we will never abort, and that's how we get locked in that is busy state. You'll recall from earlier that we said that the onEnd function is always called regardless of what happened in the action. We're guaranteed to get onEnd to be called. So it seems like we might be able to do something about ending only if we end with status success. Because if we issue a new command, we will never have returned status success. We will have returned only status running. So let's cut this bit right here about the amount value equals gatherable supplies.value.endGather. Then let's redefine our protected override void onEnd. And in there, we can check the status of this node by doing if current status is equal to status.success. If that's the case, then we want to set our amount.value to be the gatherable supplies value.endGather. In any other case, if this node was canceled, anything else, we want to abort gathering to ensure that we release this gatherable supply. And as long as we're in here, we can tell on our gatherable supply that we may destroy a game object. So there is the potential that this gatherable supply script ends up being null. Let's scroll back up to onStart and check if the gatherable supplies value is null. If so, we'll return failure. That should also protect us on update, because once we've begun gathering, we have checks in place to ensure that we're the only ones manipulating that value. But on end, again, our gatherable supplies value could be null. We're protected again on the first one because gatherable supplies value can't be null if we end in success. Let's just attach our guardian pattern here. If the gatherable supplies value is null, let's just return early and not do anything else. We obviously can't abort or end the gather if the value is null. We actually have a similar problem in another class, the move to gatherable supply action. We have a reference to our gatherable supply here, and when we try to get target position, it relies on our supply value. And we also reach for that supply value and get a scriptable object reference in onUpdate. We also reference it earlier in onUpdate to check if it's busy and if the amount is greater than 0. So we can see there's something we need to do here to make this more resilient in case that object gets fully gathered. Let's walk through a scenario. If an agent has begun gathering and gathers the last remaining supplies on a gatherable supply, in that case, we're going to come on our behavior tree, we'll move back to the command post and restart back up the top. We'll get our avoidance quality set, and then we'll re-enter our move to supply or nearby not busy supply. That means we'll enter start and we'll try to move to a target position, but that can be null. So if our supply is null, we have a problem, right? We might just think, oh, well, we'll just do our guardian if here, or supply.value equals to null, return failure. That doesn't quite work because then we'll get stuck right here trying to search for some supply, but never actually searching for it. So before we do get target position, we can check if the supply value is null, and then we need to do something like our overlap sphere. So since we're going to need to do basically the same thing here, it'd be nice to extract this into a function. So let's take this, right click, refactor, extract method, rename it to find nearby not busy colliders. Back up and start, if that supply value is null, we can try to do that, but remember, this also depends on having a scriptable object. So we need to keep a reference to that when we first enter and supply value is not null, so we can keep going back to that same type of gatherable supplies. At the top, let's make a private supply SO. And before we do if supply.value is null, let's check if supply.value is not equal to null. If it's not null, then we'll assign supply SO to be supply.value.supply. We can then do else if supply.value is equal to null and the supply SO is null, we can return a failure. That means that we are actually stuck. We can't try to search for new gatherable supplies because we don't know what type to search for, and the type that we were assigned is gone. In any other case, we can do collider array, colliders equal find nearby not busy colliders. That'll do that search nearby. And we can again check just like what we do on update, if colliders.length is greater than 0. And let's define the else case first. That's just a little easier. Just return status.failure. Back up in the if block, assign the supply value to colliders indexed by 0.getComponent gatherable supply. Now our onStart is pretty big, and a lot of it's validation. So why don't we do a little refactor here, move supplies mask up to the top of onStart. And all of this can be refactored into basically should we fail. So let's cut all that and say if not has valid inputs, return status failure. Let's scroll down a little bit below our onUpdate. Define private bool has valid inputs and paste all that code in here. And down here, wherever we have these return status failures, we're going to want to return false, saying that we do not have valid inputs. But before we get too far into that, we can also simplify a little bit this if and else. For example, the second else if here can be combined with the first one. We can just add or parentheses and then paste that supply.value equals null and the supply SO is equal to null. Then if our supply value is not null, we'll assign that supply SO. We'll still do all this with our colliders. And really, we need to also sort. We don't want to just pull our colliders here. We do want to sort that. So we'll come back in a second. Let's replace our status failure here to be false and return true at the end, saying if we made it there and didn't hit any of these return falses, then we're going to assume we have valid inputs. Now, do you remember how to sort this colliders array? That's just array.sort colliders and a new closest collider compare with the agent transform position. Now our onStart will validate some stuff, we'll override supply if needed, and cache our supply SO to keep everything running smoothly. One more thing to make sure our start is working properly is in our find nearby not busy colliders, we want to make sure we're using our cached reference of that supply SO, not directly referencing supply.value.supply. And we're almost done. In update, we have a similar problem here, where potentially we have made it to our target destination, but then that supply has been destroyed. So again, if supply.value does not equal to null and not supply.value.isBusy and supply.value.amount is greater than 0, only in that case can we return success. In any other case, we're going to find those nearby not busy colliders, sort them, and set our destination. As you can see, gathering is not quite as easy as it really seems like it should be. When we play AAA RTS games, it's really easy to take for granted some of the interactions that are there. But you can see just in the single action about moving to a gatherable supply, we've got almost 100 lines of code in here. And as long as we're performing validations, our move to target game object action has the same problem that our move to gatherable supply action had. We are referencing our target game object value, but it's possible that was destroyed. Luckily, this is a much simpler action. Do you have any idea about how we can easily solve this potential null reference problem in this action? All we have to do is add to our guardian pattern, or target game object.value is equal to null, return failure. This one doesn't have any auto retargeting or anything of that nature, so it's much more simple. Let's come back to Unity, and just to really showcase this working totally right, I'm going to disable a couple of minerals so we don't see a unit that just tries to gather one and the other immediately. We'll see them move, and we're going to set this mineral to have 8 supply once we start. So let's click play. And remember, we want to take this unit and send them to gather while the other unit is already gathering to try to trigger an error. Set our minerals to 8, send 1. Send 2, and we see that correctly routes, and our second unit comes back and starts gathering again. So now our gatherers will automatically target new patches of gatherable supplies whenever a gatherable supply becomes depleted. We've caught all those corner cases, we don't have any null reference exceptions, it looks like it's working pretty well. Of course, once all of these are depleted, they'll sit idle because they don't know where to go. And that's a pretty standard interaction on an RTS, so I think we can live with that. That's all we've got for this lecture. When you're ready to move on, I'll see you on the next one.